Hello, today I'm going to have a look at some coordinate geometry, and in particular we're going to have a look at finding the distance between 2 points. So this is if I've got two coordinates that I know. So let's say, for example, I have the coordinate 1, 5 and the coordinate 6, 2. Now, this picture is not to scale. What you'll find in maths often is it's really useful to draw a picture so that you get the general idea of how things are intersecting, and it doesn't really have to be very accurate. You just need the things there. So here I've got my picture, and we're looking to find the distance between these 2 points, so the length of this line segment joining them. The trick here is to think of it as a right-angled triangle. And we're looking for the hypotenuse of the right-angled triangle. So if I can find the other two sides, I can then use Pythagoras. How long's the bottom bit? Well, I'm starting at 1, I'm going up to 6, so I'm going across 5. What's the side? Well, I'm starting at 5, I'm going down to 2, so I'm going down 3. So the length of the side is 3. And then I can just use Pythagoras. I can say that the length of this side is going to be equal to the square root of 5 squared plus 3 squared. Well, 5 squared is 25, 3 squared is 9, so this is the square root of 34. Now, there is a formula for this. I think it's far better that you understand that what you're doing is just Pythagoras, and if you remember it's Pythagoras, you won't go wrong in the exam. The formula is, well, we're going to do Pythagoras, and we're going to do the bottom number, and to do that we're doing the change in x, and we're squaring that, and then we're adding on the change in y squared. I can write this differently if I say I'm looking at the coordinates x1, y1. As you can see, I'm really imaginative with my coordinates, and x2, y2. Then the formula becomes the change in x. Well, the change in x is what I need to do to go from x1 to x2. Well, that is x2 minus x1 squared. Because I'm squaring it, it actually doesn't matter which way around your x's are. And then we're going to add on the change in y, which again is going to be y2 minus y1 squared. So that's a formula which you might see. I've shown it to you so that you recognize it, but you are far, far better just understanding that what you're doing is applying Pythagoras. Let's have a look at this in an exam question. So here's a question from the OCR January 09 Core 1 paper. It says the line with equation 3x plus 4y minus 10 equals 0 passes through a point A, which is at 2, 1, and the point B at 10k. And the first bit says find the value of k. So the first thing to do with this sort of question is to understand what it's asking for. Well, we've got the equation of a line. We've got one coordinate which we know everything about, one coordinate which we don't know everything about, and we're asked for a case, which is part of our B coordinate. Well, because I know my x value in my B coordinate, I can use that to find my y value. So I've got my equation of the line, and the equation of a line is really a relationship between x and y. So we can use the fact that if I do 3 times x plus 4 times y minus 10, I know I must get 0. Well, if x is 10, we can work out our y. I can say 3 times 10 plus 4 times y minus 10 equals 0. And now I just solve this equation. So I get 30 plus 4y equals 10. 4y equals minus 20. So y is going to equal minus 5. And because my y value is minus 5, and k here is my y value, I can say that k is equal to minus 5. It's really important with this sort of question that you make sure you finish by answering the question you're asked. We were asked to find the value of k, not the value of y. So make sure when you're doing this sort of question that you do finish it off at the end. The next thing we're asked for is to calculate the length AB. So we know that A is equal to 2, 1, And we now know that b is equal to 10 minus 5. And we're looking for the length between these. So I'm going to start off with a at 2, 1. I'm going to have b at 10 minus 5. Again, I'm drawing a picture because I think drawing a picture is a really useful thing to do to understand what's going on. But it only has to be a sketch. It doesn't have to be to scale. Here I've got my right angled triangle, which we're going to use Pythagoras on. How far am I going across in my x-axis? Well, I'm going from 2 up to 10, so I'm going across 8. And how far am I going on my y-axis? Well, I'm starting at 1, I'm going down to minus 5, so I'm going down 6. Now, because I've done lots and lots of this sort of thing, I immediately recognise this as a famous right-angled triangle, the 3, 4, 5 triangle, or in this case 6, 8, 10. So I can say that the length between A and B is 10. But if you don't spot that straight away, all we're going to do is Pythagoras. We're going to say it's a right-angled triangle. I know that if I do 8 squared plus 6 squared, I'll get 64 plus 36 square rooted, which is 100 square rooted, and that's 10. Now, if you've had me as a teacher or any other person at King Edward's College, you will be moaned at lots and lots about remembering plus or minus when you square root. Here, because we're looking for a length, I know that the length must be positive, and that's why I've not worried about the plus or minus. So the distance between A and B is 10. I'm going to have a go at the OCR Core 1 January 12 question, but I've adapted it. I've changed the numbers because I think it's such a nice question that you'll want to practice it yourselves. The line L has gradient 3 and passes through the point 2, 1. So key information, the gradient is 3, the point 2, 1 is on the line. The point B is also a point on the line, such that the distance from A to B is 2 root 10. And we're asked to find the coordinates for possible points. Now, I have shown you a formula for the distance between 2 points. There is also a formula for the gradient between 2 points. And you could do horrible simultaneous equations to find out this. I would hope that having seen this, rather than doing that, you would draw a bit of a picture and put A on, because we know that A is at 2, 1. Draw in our line. Now we need to think about the other information we've got. The gradient is 3, which means if I go across 1, I've gone up 3. So every time I go across 1, I'm going up 3. Across 1, up 3. Or, the other way to think about it is if I go across x, I'm going to go up 3x. I'm going 3 times up for every once I go across. Now, we want the length of the distance on the hypotenuse of my triangle to be 2 root 10. So I'm going to use Pythagoras. I'm going to say x squared plus 3x all squared is equal to 2 root 10 squared. So this is x squared plus 9x squared. It's really important that you remember to square the 3. Well, that gives me 10x squared. And on the right-hand side, I get 2 squared is 4 times root 10 squared. Well, root 10 squared is 10, so this is 40. And then I can see straight away that x squared is equal to 4. So x equals plus or minus 2. And I get plus or minus because as well as going to the right, I could have gone to the left. And now that I know that x is 2, I can say I'm going across 2 and up, well, I'm going up 3 times 2, so I'm going up 6. If I start at 2, 1, and I go across 2, I've gone across to 4, and I've gone up 6, so 1 plus 6 is 7. So this is one possible coordinate for B, and then the other possible coordinate, so I start at 2 and I go backwards 2, well that takes me to 0, and I'm at 1 and I'm going down 6, so that takes me to minus 5. So that's my other possible point. So there were 2 points we were asked for, and the 2 points are 4, 7, or 0 minus 5. So I hope now you understand the importance of being able to draw a picture, understanding the Pythagoras involved, extracting the key bits of information from a question. These are all things that you'll get with practice, and I really do recommend just having a go at lots and lots of questions similar to this, so that you really get a feel for what's going on with the mathematics. It's far better to understand what's going on than to just follow formulas. I hope that's been useful to you and that you'll make use of the other videos on coordinate geometry.